Hello, my name is Gui. I will introduce our project here, peeking ahead of the field study, exploring VLM personas as support tools for embodied study in HCI. There are many evaluation methods in the HCI. One important method is the field study, which collects data by observing phenomena in their natural environment rather than in a lab. Field studies are necessary when researchers want to capture participants' authentic behaviors and genuine feelings. For example, in the research area of car-pedestrian interaction, field studies are often used to observe how pedestrians move and make decisions when interacting with vehicles in the real-world environment. However, field study is hard to conduct. We need to rent equipment and large space for a long period. Multiple experimenters must collaborate to keep the procedure smooth. The study also needs to be repeated many times for all participants. Therefore, I always work with a strong team to conduct the field study. We then propose using VLM personas for evaluation, using VLM-based simulation to approximately field study results. The procedure is that the VLM personas watch the videos and provide response. To demo it, we first prepare the case study, which is the scenario, and define the task for the VLM personas. The task is the VLM personas decide when to cross in front of an autonomous vehicle. Since there is no driver to provide cues, it must carefully observe the vehicle to make the decisions. There are two behaviors of the autonomous vehicle: stop to ask pedestrians go first, or not stop. We activate the self-driving mode with timing fully controlled. To convey its intentions, the autonomous vehicles use one of the three interfaces: an animated eyes, either looking at or not looking at the pedestrians, a colored light strip showing either green or red, and no signals as the baseline. This resulted in a total of 6 conditions. We first show the simulation demo. We start by selecting the persona and choosing the test case under the 6th condition. We then run the simulation. Here we can see the persona's trajectory. The persona first moves forward and pause for a while to observe, and finally decide to cross the street. By clicking each decision point, we can see the view that the persona sees at that moment. Scrolling down shows the reasoning behind the decision. After the simulation finishes, we can watch the combined video, which shows the sequence of views selected by the VLM. Next, we explain how the video simulator was developed. The process consists of 2 steps. Step 1 is constructing the VLM persona. Step 2 is the development of interactive video simulator. First, the VLM persona is modeled by the real people. We conducted the questionnaire with 20 participants. We collected demographic data, Big 5 personality traits, and open-ended written response, reflecting participants' attitude toward the autonomous driving. We then used the data to craft the persona prompt. An example of the prompt format is shown here, with the actual data hidden for privacy. In the step 2, we implemented a video simulator to present VLMs with human-like visual perception. We face a challenge here. Pre-recorded video cannot respond to VLM decisions. For example, a VLM persona may decide to stop while watching a video. However, In the pre-record video, the scenes continues to move forward, which conflict with the VLM decision. In addition, pre-record video that include experimental movement may bias VLM persona's choice. To design the solution, we borrow the idea from choice-based game, while the story branches according to the user decisions, leading to multiple endings. In our case, the green marks on the floor served as the branch point for the VLM to make decisions. To make the decision-based video simulator for the VLM persona, we filmed each condition multiple times from different positions. This provided multiple video views from different positions at the same time. In the simulation step, the VLM first watch 1 second video clip and make decision whether to move forward or stop. Their choice determine the next one video clip. As you can see, the upper view moves slightly closer to the road because the VLM choose to move forward. We then repeat the step until the end of the process. If the persona keeps choosing to move forward, it will reach at the edge of the road as the vehicle approaches closely. If the persona keeps choosing to stop, it will remain far away from the road at the end. This created a final video composed of the VLM select views. We ask the VLM persona's question after the simulation. The videos selected by the VLM will merge to simulate the persona's memory. This memory supports the VLM in answering questions about decision confidence and trust in the autonomous vehicle. So, to sum up, field study with human are necessary but costly. We therefore propose using VLM-based simulation for the evaluation. The goal is to reduce study cost while maintaining data quality. It is obviously that the cost is reduced, but data quality is unclear. So, we validate it with a comparison study. We conduct 2 studies. The baseline was the field study with human participants, and the proposed study was the video simulation with VLM personas. We then compare the VLM-generated response with human response. The first metric is the crossing time. In the figure, the y-axis shows the distribution density, and x-axis shows the time for participants decide to cross. The p-value for the mean of crossing time shows no significant difference, suggesting that the VLM can capture the overall trend of human behavior. However, the standard deviation differs, indicating that while VLM-generated behavior aligns with human pattern, it is less diverse. For the questionnaire rating of the subjective feeling, we compare the confidence and trust. When the evaluation referred to the tester themselves, the VLM tend to produce overestimate response. In contrast, when the evaluation concerned an external object, the VLM's response closely match those of human participants. Based on this observation, we summarize 2 key findings to suggest how researchers should use the VLM persona to simulate the result. Please check our paper for more information. Thank you.